Hello, welcome to the adventure. None of us signed up for this, but here we are nonetheless. In order to get through the rest of the semester, we're going to use a software simulation tool called Multisim. In eCampus on the left here, you will see a link called Install Multisim. If you select that, you're presented with the instructions to install Multisim. If you have not yet done so, please install Multisim now and pause this video. After you have installed Multisim, you can launch it by selecting the Windows icon in the lower left and then just start typing Multisim, M-U-L-T, and eventually it will show up in the list here. You can select it and it will launch. Go ahead and do that now. When you bring up Multisim for the first time, you will see an empty palette called the desktop or the bench, and this is the place where we will simulate our circuits. Now what I'm going to do in this video is set up the circuits that will be required to do your Lab 4 Multisim assignment. So I suggest that you follow along with me and pause the video after each circuit is set up and answer the questions and collect your data, then come back to this video for the setup of the next circuit. So let's get started. The first circuit that we will put together is the resistor in series with the capacitor. So let's select those components to begin with. Up here is a menu that is used to place our various components and circuits. Everything we'll need as far as inductors, resistors, and capacitors will be in the Place Basic menu. So if I select that and I scroll down, I see that resistors, capacitors, and inductors are right next to each other. So I need to start with the resistor, so I'll select that, and it loads a whole bunch of resistors. And as luck would have it, I need a 1000 ohm resistor, and the 1000 ohm resistor is automatically selected. So if I press OK, I can come in here and just drop it. Multisim named it resistor 1 for me, and I can see the value is 1000 ohms. If I happen to grab a resistor that was incorrect for the resistance, I could just double click here and I would change this value to whatever resistance I need. I also need a capacitor, so I'm going back to Place Basic. And here is my menu again. Now I'll select capacitor, and I see a whole lot of capacitors here. So I'm just going to pick one and put it on the palette here. And it's 0.2 microfarads. I actually need 0.05 microfarads, so I just change it in there. I double clicked on the value and edited it inside of the menu. How do I connect these together? Well, I just take the mouse and wait until it turns to that symbol there. Click, drag over here, click again, and those are now connected. Next thing is that we need to connect it to our signal generator. So come over here to our tools and hover until you get to function generator. Select that, place it up above, and we see some connections that should look somewhat familiar. We see a plus on that's our high connection. COM stands for common ground, and the negative we're not going to use. So we're going to use the high connection, which is the plus, and the common ground. If I double click on this symbol here, I get a menu that pops up that allows me to select our waveforms. Now in the lab it wants us to have 1000 hertz, so I can either type 1000 and have hertz there, or I can just type 1 and select kilohertz. Either one will get us to the same place. The waveform I want is a square wave. The duty cycle just refers to the amount of time that it is on compared to being off. So 50% duty cycle means it is on half the time and off half the time. Next is the amplitude. The lab wanted us to do 5 volts VPP, but Multisim only lets us do VP. Whoops. So I need to convert 5 volts peak to peak to peak voltage. I know that the peak voltage is 1/2 of the peak to peak voltage, so I want that to be 2.5 volts peak. And then that will give me a wave that has a maximum of 2.5 and a minimum of negative 2.5. What I want is a wave that goes between 0 and 5. So this is where we do the offset of 2.5 volts. Press return, press return. So my function generator is set up, so I can close that window. Xing out of that menu doesn't X out of the actual generator. And now I'm going to set up my circuit. And I do that by connecting the positive to one side. So if I click right there, I can make a corner. And my common comes to the other side. And I'm telling you right now that I'm setting this up incorrectly. But I'll tell you why in a moment. So this looks like a circuit that is connected to my signal generator in Multisim. Next thing I want to do is get my oscilloscope. And so I'm looking for the Tektronix oscilloscope. And here it is right there. If it's not in your list, you might need to click this arrow here. That'll bring up some more instruments. But my Tektronix oscilloscope is right there. Now, what the lab asks me to do is connect my oscilloscope across the capacitor. But this common here, this is the common ground. That represents the black lead from my signal generator. The black is coming from the common ground and the red is coming from the positive side. So I see that I want my common ground to be connected to the capacitor, and the way I've set it up, my common ground is connected to the resistor. So this is actually incorrect. What I need to do is select those wires and press delete and change the order of my capacitor and my resistor. So you just click on them until you see that box. Whoops. And then drag and drop. And then wire them back together. Okay, my resistor is connected to the high side and my capacitor is connected to the common ground. And then once again, my oscilloscope, one side of it is connected to the common ground and the other side is connected to the other side of the capacitor. So inside of Multisim, if I double click on this, lo and behold, that looks a lot like our oscilloscope that we use in the lab, right? It looks a lot like the oscilloscope we use in the lab. So I notice that it's got 4 channels, 1, 2, 3, 4. We're only going to use channel 1 here. But I connect to channel 1. If you look on this icon here, you see the 1, 2, 3, 4. If I want to measure across the capacitor, I want to wire from channel 1 to this side of the capacitor. And then the other side, so what I just drew there, that is this probe. the other probe on the oscilloscope, I designate that by putting the ground symbol on my circuit. So go over to now Place Source, click on it, and I want to select now Power Sources, and then I want to select Ground. If I select Ground and I connect it to my common ground, that's the same thing as putting that connection on this side of the capacitor. So now I have my oscilloscope hooked up for the first circuit in the lab. And now the thing that we need to do is simulate. To start the simulation, you press Run right here or press F5. So I press that and nothing happens on my oscilloscope. Well, this is a very accurate simulation. We have to turn the oscilloscope on. So if you click on the power button down here, we'll see a trace begin to appear. And just as in the lab, we're going to hit auto set. And I'll warn you right now, the auto set on this isn't as good as the auto set in the lab. You'll have to play with the seconds per division knob here. And also probably the volts per division knob there. Remember, the volts per division is changing this number here. So 2 volts means that each time I get to another horizontal line, that means I've gone up 2 volts. So if I look at this, I'm going from 0 volts up to about 2.5 divisions. 2.5 times 2 is 5, which corresponds with my 5 volt peak to peak that I set up in the function generator. This number here, that determines the amount of time between the vertical lines, and so that is changed by adjusting this knob. And you adjust the knobs by clicking and rotating the mouse around the knob. Okay. Let me get that to 50 microseconds. I'll tell you why in a second. All right, we'll do our auto set again. Whoops, didn't want to do that. What I'm going to do now is do a single. If I press this button, this will start and stop the oscilloscope. This button here will give me 1 screen's worth of data. So if I do that, I can adjust my vertical scale, and I can adjust my vertical position. I can adjust my horizontal position. Okay. So now you're in position to do some measurements. To do that, we use the cursor function. Pressing on the cursor, up here we see type, and the types are either voltage or time, just like in the lab. And so if I want to do a voltage measurement, I would select my cursor position, maybe at the bottom there. And one big thing that is different between this and what we do in the lab is that we would push this button to get to cursor 2. That is not the case here. If you look underneath this knob, it says cursor 1, and under this knob, it's cursor 2. This is the one that we are going to use to control cursor 2. All right, so I don't really care about the absolute values of cursor 1 and cursor 2. I care about the delta. And so the difference in voltage between this cursor and that cursor is 5.18 volts. What is missing if we go to the time cursors is, if I do cursor 1, and cursor 2, what is missing is that delta V, remember in the lab our oscilloscopes told us a delta V between that point and that point. That is missing here. So this is why I set up my seconds per division to be 50 microseconds, because that corresponds to the time constant of our first circuit. So if I move my horizontal position such that it is starting, let me move the cursor out of the way, such that the transient response starts on one of these vertical lines, then each vertical line to the right represents another time constant that is passed by. So if I now put my cursor 1 on the beginning of the transient response, if I move my time constant there, I can verify that it is 50 microseconds. But that's really not what I'm after, is it? I'm after the voltage, so I need to change my cursor type to voltage, and now the voltage that I've risen in one time constant will be the amount I've risen between this line and that line. So if I measure right there, I see it's about 3.4 volts. After two time constants, I'm going to measure where it crosses this next vertical line, and so that's about 4.78 volts. So at this point, I want you to go into the lab and follow the instructions through the first circuit. Come back and I'll show you how to set up the second circuit. To get to the second circuit, I just X'd out of the oscilloscope, and now I need to stop the simulation so that I can edit my circuit. Instead of a capacitor now, I'm going to do Control X and then just Control V down here because I'm going to need the capacitor later for my RLC circuit. I need to find an inductor. So I go back to Place Basic, select now Inductor, and what I want is 10 millihenry. So I'm just going to grab something that has a lowercase m at the end. Oops, I don't want to place that twice. Close. I'll delete this one. And I'll edit this one. I don't want 0.39 millihenry. I want 10 millihenry. Move it up into my circuit. And now I might have to delete some wires. Sometimes it's easier just to start over. And then I want to connect my channel 1 on this side of the inductor. And now the other side of my oscilloscope, the ground probe, is designated by where I put this ground symbol. So I'm set up. I don't need to change anything in the function generator. Bring this up, restart the simulation, restart the oscilloscope, take one trace, and we're good to go. So you can adjust the vertical scale here, and you can adjust the time scale here. You would now use your cursors to do pretty much the same thing and choose the value here. I believe the time constant for this circuit is 10 microseconds, so if you can, set it to 10 microseconds so that each, and then put the horizontal position so that it starts on a vertical line. So each time you pass a vertical line now is one additional time constant. Go ahead and complete the resistor inductor portion of the lab and return to this video. The last step is we're going to set up the RLC. So I need to stop my simulation, going to remove my connections here. If I go down to the RLC circuit, the resistor is in the middle and my capacitor is connected to my common ground. So the common ground of the function generator and the ground for my probe are connected to the capacitor. So that is the order I need to set up my circuit. The inductor goes to the left, and the resistor needs to go to the right. And if you're OCD, like I am a little bit, it's kind of difficult to get things looking exactly how you want them to look. All right, so I connect the inductor to my high, the resistor's in between, and capacitor, the other side of the capacitor is connected to the common ground. And then I want to make sure my ground is connected right there, since that represents that connection for the black alligator clip. Then I need to connect my oscilloscope probe. I think that's getting in the way. Okay, so I should have achieved what I set out to achieve. I forget if it's 0.05 or 0.01. To change, it's really easy. Just stop the simulation, come in here, select it, and change it to 0.01. Okay, and it is updated. If I now start the simulation, double click on the oscilloscope, tell it to start running, do an auto set, take one screenshot worth of data and zoom in on the time. Okay, and so we see is just barely a hint of an oscillation, but to see the actual oscillation, I believe it tells us to change this back to 51. So I just type 51, ohms is over here. If I restart the simulation, restart the oscilloscope, take one screen worth of data. Well, no, let me auto set first. And then take one screen worth of data and stretch it out. I see the familiar oscillations that we were getting in the lab last time. So this is how you need to set up your circuits for Lab 4 Multisim. Common things to forget is the placement of the ground connection on the common ground of the function generator. Also, forgetting to start or stop the simulation. That's anytime you change something here, you need to stop the simulation, but then you need to remember to come back here and start it again and restart your oscilloscope, then the auto set, then the single. So the sequence there is run, auto set, single, and then adjust your waveform so that you can come in and measure the peak-to-peak time, or the time between your peaks, in order to get the period and the frequency. If you have any questions about this video, please tell me the time mark in the video where you have the question. If you have issues with your multisim, go ahead and save your multisim and email it to me. That would be the best way for me to see what you're doing, and I can reply. Other than that, I wish you the best of luck. I think it will go fast for you once you get the hang of the oscilloscope. It'll go faster than in the lab because you're not going to have as many hookup errors as you had in the lab. So again, please don't hesitate to contact me with questions, and I wish you good luck.